All right, so we're going to continue and wrap up section 3-4. Okay, so before we get to the proofs, we're going to do a few problems. And the problems are going to be similar, some of the problems that what we did in section 3-3. They really are, okay? They really are. They're going to just have different directions. Like, I got to write that bigger. You guys can't see that. So they're going to say, the directions will say something like this. Find value of x which makes the lines parallel. So the old directions said something like, you know, the lines are parallel, find x. So now they're saying find a value for x that makes the lines parallel. Just the converse, okay? They're just switching the order there. So find a value for x that makes the lines parallel. We're going to see what kind of angles those are. Those two are consecutive interior. So consecutive interior angles have to be supplementary. So we're going to say something like x plus 4x equals 180, or 5x equals 180, divide by 5, and x equals, I think it's going to be 36. So a value of x, when x is 36, those lines would be parallel. Okay? And then there's certain problems that I see in the book, and some that I like and some that I don't really care for. This is always one of my favorite problems. I don't know why. Nothing really to it. But it'll say something like this. Okay? And then we have a ray coming off of there, and then another ray coming off of there, and this is E, and this is A, and this is B, and then they say that this is 62 degrees, this is 58 degrees, and then over here, okay, we have CHD, CHD, and then this is 59 and this is 61, and they'll say, are any rays parallel? Are any rays parallel? So the first two I want to check are EB, ray EB, is that parallel, question mark, okay, to HD. So let's look. Here's EB, here's HD. In order for those to be parallel, these two angles would have to be the same, because then we could say that the angles are corresponding angles, so my lines are parallel. That says 61, this says 58. Are they the same? No. So those lines are not parallel. Now let's look at ray EA and ray HC. And we're going to look at the same rule. We're going to try to see if their corresponding angles are equal. Well, this angle right here is 62 and 58, and 62 and 58 is 120. And then this angle here is 61 and 59, and that's also 120. So because these angles are congruent, I can say that those lines are parallel. And if they asked for a reason, we would say the corresponding angle converse. Okay? So that's that. Now let's look at a proof. Okay, these proofs, I think they're going to trick you. I think you guys are going to get tricked in the proof. we're going to try it. Okay, I'm going to put it out there for you. I'm going to see if you guys can get it. All right. So I'm going to put my picture, and I'm going to put some angles in here. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and I'm going to say that the given is that angle, let's see, angle 2 is congruent to angle 1. And we're going to try to prove that, we'll say that's M and that's N. M is parallel to N. Okay, that's what we're going to try to do. So, let's see if we can do this. So we put our given in always. Angle 2 is congruent to angle 1, and the reason for that is it is given. So I'm gonna, 2 and 1. Now, I didn't want 2 and 1. I wanted 3 and 6. I am sorry. Let's make that change. Make that change. All right, so angle 3 and angle 6. I'm gonna make it here too. Angle 3 and angle 6. So I go over here and I say that's angle 3, and I say this is angle 6, and I look at those two angles and I say I know what those two angles are. I know the relationship between those two angles. Those two angles are related. They are alternate interior angles. So for my second step, I can do this in one step. I can say that M is parallel to N, and the reason is my AIA, and then you have to have the converse. If you don't have the converse, unfortunately, I cannot give you credit. Okay? When they give you angles and you're proving lines are parallel, you have to put converse. So I want you to try that again. Okay? And I'm going to tell you that we want to prove that M is parallel to N, but you cannot use alternate interior angle converse. You have to use something else. So pause the video and see what you guys can do. So I hope that you paused your video. I really do. Okay, I really do. Let's take a look. So I think what you guys did was, this is what I think you did. So let's look. Step 2. Angle 3 is congruent to angle 6. I'm not sure what you did. I'm trying to think of where I was trying to catch you on here, or try to see if you guys get this. I don't know. So I can't use alternate interior angle converse, but I can, if 3 is congruent to 6, okay, I am going to say that angle 3 is congruent to angle 2. Now, how can I say that angle 3 is congruent to angle 2? How can I say that these two angles here are congruent? Anybody know? Yeah. The vertical angle theorem. Okay. Now, in step 3, if 3 is congruent to 6 and 3 is congruent to 2, what can we say based on those statements? I can say that angle 2 is congruent to angle 6 because these two things are congruent to the same thing. And the reason for that is transitive. And so then in step 4, if 2 is congruent to 6, I can say my lines are parallel. And the reason I can say my lines are parallel is the corresponding angle converse. Okay, so I didn't use alternate interior, but I found another way. And whenever you find another way, you always have to use transitive. So I hope that makes sense to you guys. I do. We have a lot of problems to practice in 3-4, so if you didn't quite get it, I'm hopeful that when we take a look at it and closer look and through Teams meetings and such, that it will make more sense. All right? All right? All right.